Hi, everybody. AP Review 8, Multiple Choice 2. AP Review 8, Multiple Choice 2. No calculator, 28 questions, 55 minutes. Let's go. Okay, number 1. F equals e to the 2x tan inverse x, and we want f prime of 1. So we need the derivative, which requires the product rule. 2 times e to the 2x tan inverse x plus e to the 2x times 1 over x squared plus 1. That's f prime of x. We need f prime of 1, which is 2e to the 2 inverse tangent of 1 plus e to the 2 over 2. Inverse tangent of 1, so you're supposed to know that that's pi over 4. So I've got e squared over 2, because these cancel, times pi plus e squared over 2. If I factor in e squared over 2 out, I get pi plus 1, and that looks like choice E. Choice E for number 1. Okay, number 2. The integral from 1 to 8 of x to the minus 2/3 power. So that's going to be x. I have to add 1 to this, which is adding 3/3. This is going to be this. So if I bring that down, they cancel. There's nothing in front, and I subtract 1, and I'm going from 1 to 8. Cube root of 8 is 2. 2 to the first is 2. Okay, so it's just cube root function here. Cube root of 8 is 2. 2 times 3 is 6. Minus cube root of 1 is 1. 1 times 3 is 3. And I get 3. So E is my answer again for number 2. For number 3, let's see what we've got. We've got f equals e to the minus x plus sine x minus cosine x, and they want us to find f double prime at 0. So f prime would be negative e to the negative x plus cosine x, and the derivative of cosine is minus sine times that minus is plus sine. Now f double prime is going to be the derivative of this derivative, which is e to the negative x. The derivative of cosine is minus sine, and the derivative of sine is cosine. We want f double prime at 0, so that's e to the 0 or 1, minus the sine of 0 is 0, plus the cosine of 0 is 1, and so I end up with 2 or e. Wow, 3 e's in a row. They must be really in a cranky mood to have set us up with that. So many students would be like, that can't be. What's up with this? 4. Yes, they are playing with you. Just ignore it and move on. 2xy plus y squared equals 11, and the ordered pair is 1, negative 2. Okay, so we want to find the slope at this point, so we want the derivative at this point. It's going to be 6x minus, product rule, 2x times dy dx, because the derivative of y with respect to x is called dy dx, plus 2y. Now we've got our plus sign here, and 2y dy dx. Remember, the derivative of the outside squaring function is 2, leave the inside function alone, then times the derivative of the inside y with respect to x, equals the derivative of 11 is 0. So now I've got 6x minus 2x dy dx minus 2y plus 2y dy dx equals 0. I can put in this ordered pair now, or I can solve for dy dx. I think I'm going to solve for dy dx. Negative 2x plus 2y dy dx equals 2y minus 6x. So dy dx equals 2y minus 6x over negative 2x plus 2y. So I see I can take a 2 out of all of those, and I think I will. That's going to give me that's going to give me y minus 3x over negative x plus y. Let's plug in our values. 1 for x, negative 2 for y, negative 2 minus 3 times 1 over negative 1 plus negative 2. So I get negative 5 on the top and negative 3 on the bottom, which is 5/3 or D. I get D for number 4. Hey, and guess what? That wasn't an E. Why is that not focused? Oh my God. I'm so sorry. Something must have happened. There. That's better. Okay. I'm not going to do those first problems again. Sorry. I don't love you that much. Okay. What about 5? 5 is the derivative with respect to x of the ln of secant x. Okay, so this is chain rule. The derivative of the outside function is going to be 1 over the inside function times the derivative of secant. Well, the derivative of secant is secant x tangent x. So these cancel, giving me tangent x, and that is choice B. Choice B for number 5. 6. 6 is the integral from pi over 6 to pi over 4 of 2 sine 2x cosine 2x dx. Okay, so, if I remember my trig identities, this is actually sine 4x from pi over 6 to pi over 4 dx. And that's a pretty easy antiderivative and evaluation. Sadly, most people don't remember their double angle formulas, and so as a result, I have to say u equals sine 2x, du over 2 equals cosine 2x dx. This is a u sub problem. Now, when I rewrite this with u's, I've got 2u du over 2. So these will cancel, and it's just u du then. Let's use some u bounds here. If I plug in this x value, 2 times pi over 6 is pi over 3. The sine of pi over 3 is root 3 over 2. And then I'll plug in a pi over 4. 2 times pi over 4 is pi over 2, and the sine of pi over 2 is 1. So my antiderivative here is going to be u squared over 2 from root 3 over 2 to 1. If I plug in a 1, I get 1/2. If I plug in a root 3 over 2, root 3 squared is 3, 2 squared is 4, so I have 3/4 over 2, which is 1/2 minus 3/8, which is 1/8. I've got 1/8 as my answer here, and that is B. B for number 6. Okay, let's take a look at number 7. The area of the region bounded by the curves y equals square root of x and y equals x squared. They intersect at a place. We're supposed to know that we can say x squared equals square root of x, and then we square both sides. X to the 4th equals x, and then we subtract x, and we factor out an x, and then we set each factor equal to 0, and we get 0 and 1. Okay, so I want to know the area of this region bounded by these two curves. I'm going to do the integral from 0 to 1 of square root of x minus x squared dx. The antiderivative of x to the 1/2 is 2/3 x to the 3/2. The antiderivative of x squared is x to the 3rd over 3, and I'm going from 0 to 1. So when I plug zeros in here, I just get 0, so that I don't have to worry about. When I plug in a 1, I get 2/3 minus 1/3 or 1/3 is my answer. And that is also B. Wow, they really like B's now. They used to like E's, but now they like B's. Let's take a look at problem number 8. Problem number 8. 8 says the limit as x approaches 0 of cosine x minus 1 over e to the 2x minus 1. Okay, so if we plug in our 0, we get 1 minus 0 minus 1. I get a 0 on top. If I plug in a 0 here, I get e to the 0 is 1 minus 1, or 0 on the bottom. I use L'Hopital's rule. The limit as x approaches 0. Derivative of cosine is negative sine. The derivative of negative x is negative 1. The derivative of e to the 2x is 2e to the x, 2e to the 2x, and the derivative of these minus 1s is 0. Now when I plug in my 0, I get a negative 1 on top. I plug in a 0, e to the 0 is 1, 1 times 2 is 2, and I get negative 1/2 as the value of the limit, and that's choice A. Choice A for the value of this limit. Okay, 9. 9 says the limit as x approaches 5 of 2x squared minus 50 over x squared minus 15x plus 50. Well, let's do some factoring, because I imagine if I plug in a 5, I get 0 over 0. So this is going to be the limit as x approaches 5 of 2, x minus 5, x plus 5. And on the bottom, we've got x minus 10 and x minus 5. Well, we can cancel those 5's out, which was causing this to be 0 over 0. And now when I plug in a 5, 5 plus 5 is 10, 10 times 2 is 20. 5 minus 10 is negative 5, and so I get negative 4 there, and that's choice A. Choice A for that one. Okay, number 10. Let's take a look at number 10. 10 says f double prime is less than 0. That means f is concave down. F prime is equal to 0 at 0, and f is greater than 0. So I have concave down, horizontal tangent, above the x-axis. So I think I'm looking at something like this, which is choice A. Choice A for number 10. Number 11. 11 says the integral from 0 to 3 of e to the sine x equals dx equals k. What do we know about the integral from 1 to 3 of x e to the sine 4 minus x squared dx? Well, don't freak out. Instead say, if I wanted to evaluate this integral, this is a u sub, with this as my u. So u equals 4 minus x squared du over negative 2 equals x dx. Look, there's an x dx. So this can be rewritten as the integral of e to the sine u du over negative 2. Now, can we get rid of these x bounds and make them be u bounds? So let's take a 1 and plug it in here. 4 minus 1 is 3. And let's take a 3 and plug it in. Did I get those bounds right? Oh no, it's 2 up here. Let's plug a 2 in here. 2 in here. 2 squared is 4. 4 minus 4 is 0. Okay, so I can pull this negative 1/2 out. Integral 3 to 0 e to the sine u du. And look what they gave me. They gave me the integral 0 to 3 of e to the sine thing d thing. So if I flip these, I can get rid of this negative. and then say that that's 1/2, and all of this was defined as k. So I've got k over 2 here, and k over 2 is choice E. Choice E for problem number 11. Great. Problem number 12. Let's take a look at 12. Object moves in a straight line with acceleration a of t equals t squared. Find the initial velocity v of 0 is negative 72. At what time does the object change direction? So find v equal to 0. Okay, so I know that a of t is also dv dt, and I want v, so I integrate dv dt with respect to t, and I get the integral of t squared dt is t to the third over 3 plus c. Okay, and then if I plug in a 0, I get negative 72. So negative 72 equals 0 plus c, c equals negative 72. So now I've got that v equals t to the third over 3 minus 72. Now we're asked, when is v equal to 0? So I think I want to add 72 to both sides, and then multiply by 3, and I get t to the third equals 216, so t equals 6. So if I plug a 6 here, and I go back to my v function, if I plug in 0, I get a negative. If I plug in a 10, I get 1,000 divided by 3, which is bigger than 72, so this is positive. And I see a sign change there, which means we change directions at 6. So we change directions at 6, and that's choice B. B for number 12. 13. 13 says, what's the x-coordinate of the point of inflection for this graph? X to the third plus 3x squared minus 45x plus 81. So y prime, 3x squared plus 6x minus 45, and y double prime, 6x plus 6. So point of inflection, we set this equal to 0, and I say x equals negative 1. And that's choice C. C for number 13. What about 14? Which of the following functions f double prime is greater than 0? That means f is concave up. And f double prime is greater than 0. But f prime is greater than that, and f is greater than that. Well, we know this can't be e to the x, because e to the x is the same for all of these, and these all say greater than. So it's not that. What else do we have here? We have e to the minus x. Okay, so I guess I want to do this. I want to say f equals e to the minus x, then f prime would be negative e to the minus x, and f double prime would be e to the minus x. Again, these are the same, and none of these are the same, so it can't be e to the minus x. Okay, what about e to the x over 2? If f equals e to the x over 2, then f prime equals 1/2 e to the x over 2, and f double prime equals 1/4 e to the x over 2. Well, this is bigger than that, which is bigger than that. I like choice B there. That's very nice. Okay, choice B. B for number 14. How about 15? 15 says f of negative 3 equals 4, and f prime of negative 3 equals 2. What's the tangent line approximation of negative 3.1? Negative 3.1. Okay, so let's build the tangent line. Y minus 4 equals 2x plus 3. Y equals 2x plus 6 plus 4 is plus 10. And I want to know what this tangent line gives me for negative 3.1. So I get negative 6.2 plus 10 is 3.8. I get 3.8, and that's choice A. Choice A for number 15. B. I'm sorry, 16. 16. Flip that page and get on to number 16. F of x equals the square root of x minus 1. What's the average value? So 1 over 5 minus 1, integral x minus 1 to the 1 half dx. Well, we know the antiderivative here would be x minus 1 to the 3 halves with a 2/3 in front times this 1/4. We can cancel and get 1/6 x minus 1 to the 3 halves, evaluated from 1 to 5. 5 minus 1 is 4, square root of 4 is 2, 2 to the 3rd is 8, 8 over 6, 4/3, minus 1 minus 1 is 0. Oh. So 4/3 is the average value, and that's choice C. Choice C for number 16. Excellent. Let's take a look at 17, and 18, and 19. I'll deal with this picture. Let's be mindful of that. At x equals 1. This is a graph of f prime that's shown to us. They tell us 3 times that this is a graph of f prime. At x equals 1. Well, at x equals 1, I see f prime goes from decreasing to increasing. F prime goes from decreasing to increasing, and that means that I have an inflection point at x equals 1. And that's choice B for number 17. 18. 18 says, on the interval, open interval from -4 to 4, how many local maxima does f have? From -4 to 4, maximum. Well, this goes negative to positive, that's a minimum. Positive to negative, that's a maximum. Negative to positive, that's a minimum. I only have one max because my endpoints are not included. So 18 is A. 18 is A. 19. 19 says f of 2 equals 1. What's the value of f of -2? F of -2. Well, this is an opportunity for me to bust out fundamental theorem of calculus and say that the integral from -2 to 2 of f prime of x dx will be equal to f of 2 minus f of -2. And so I'm going to get 1 minus f of -2 equals the integral from -2 to 2 of f prime of x dx. Or 1 minus this integral equals f of -2. So let's find the integral from -2 to 2. This area is 1. This area is 1/2. So I have 3/2. And then down here, I've got 1/2 times 1, -1 times 2. So these cancel, leaving me -1, plus 1/2 is 1/2. So that's the value of the integral. The value of the integral is 1/2, and I want 1 minus the value of that integral, and so I get 1/2 for f of -2, and that corresponds to choice C. C for number 19. Okay, let's take a look at 20. We're not using that graph anymore. 20 says the midpoint sum approximation, -4 to 2 of x squared dx using 3 subintervals of equal length. Remember, our subinterval width is b minus a over n. So 2 minus minus 4 over 3 equals subintervals 6 over 3 or 2. Okay, so I'm going -4 to -2 to 0 to 2. Those are my 3 subintervals, and I want a midpoint sum approximation. So I want halfway across these intervals. I want 1, I want -1, I want -3. So if I plug a 1 in there, I'm going to draw a picture of this. If I plug a 1 in there, that's 2, that's 1. I've got the point 1, 1. If I plug a -1 in there, I also get 1. And if I plug a -3 in there, I get 9. Okay, the subinterval width in each case is always 2. So my MRAM would be 2 times the y value plus 2 times the y value plus 2 times the y value. So 18 plus 4 is 22, and that's choice C. We've got C for number 20. Okay, what about 21? 21 says, which of the following differential equations could be represented by this slope field? Well, the antiderivative looks like x to the third over 3 plus c. What would the derivative of this function be? X squared. And I don't see x squared. So, boo-hoo me. Oh, those look like vertical asymptotes, don't they? That looks like tangent that I'm looking at. So if I'm looking at a bunch of tangents, tangent x plus c, whose antiderivative is tangent? Whose antiderivative is tangent? Whose antiderivative is tangent? I don't know. The derivative of tangent would be secant squared. And I don't see a secant squared here. All right, let me try it a different way. dy dx equals. Okay, so when y equals 0, I have this positive slope. In fact, I always have a positive slope, no matter if I plug in a negative or a positive. I also see these are all the same slope. And if I plug in different x values here, I won't always get the same y value. This is an even function reflected across the y-axis. That's not what I see. This is an odd function but shifted up 1. But that looks like x to the third, so that wouldn't be that. Tangent is the antiderivative, not that. Inverse tangent of y. Ugh. If I plug in y equal to 0, inverse tangent of 0 is 0. And I should have 0 slope at 0. I don't have a 0 slope at 0, so it's not that. It must be d. Let's take a look at d. If I plug in y equals 0, I have a positive slope. Yes, a slope of 1. If I plug in these negative y values, they get squared, become positive, and the more negative these are, the bigger the slope is. That's true. And if I plug in positive y values, the bigger the y value, the bigger the slope. And so I like choice D for number 21. Sorry, that wasn't elegant. 22. Particle moves in a straight line with the velocity v equals 4 minus t squared. What is the total distance the particle travels between 0 and 3? Okay, so when I think about this graph, that's 2, that's 4, and there's 3. And so part of this goes below the time axis, and therefore I need to split this up into two integrals. I need the integral from 0 to 2 of 4 minus t squared dt minus the integral from 2 to 3 of 4 minus t squared dt. So the antiderivative here is 4t minus t to the third over 3 from 0 to 2. 8 minus 8 thirds is 16 thirds, and 0 minus 0 is 0. Minus, and then we've got this integral, comes in two parts. It's going to be 4t minus t to the third over 3 again, but this time evaluated from 2 to 3. If we plug in a 3, we get 12 minus 27 over 3 is 9. And then if we plug in a 2, we've already seen that we get 8 minus 8 thirds, or 16 thirds. Okay, so that's 3, or 9 thirds, minus 16 thirds, which is negative 7 thirds. But we've got a minus out in front. So we've got positive 7 thirds plus 16 thirds is 23 thirds. 23 thirds is choice D. D for number 22. Okay, let's move on. 23 says the area bounded by y equals x squared and the horizontal line y equals 1. Rotated about the x-axis. Rotated about the x-axis. So my radius is my y value, and my height is this x and this x, so 2x. But we know that y equals x squared. Square root of x, square root of y equals x. So the height is 2 root y. So my integral would go from here to here, 0 to 1, would have a 2 pi out in front, would have radius times height, or y times root 2 root y, dy. I'm going to pull this 2 out. I get 4 pi integral y to the 3 halves dy. This is y to the 1 half times y to the 1, the 1. When the bases are the same and I'm multiplying, I add the exponents. That makes 3 halves. The antiderivative here then would be y to the 5 halves with a 2/5 out in front. So I get 8 pi over 5, y to the 5 halves, from 0 to 1. And so I end up with 8 pi over 5. 8 pi over 5 is choice E. E for number 23. You could have done that with washers, but I found shells to be easier. 24. Okay, we're on our last page. Y equals f of x has this differentiable function dy dx equals negative 4y, and y of 0 equals 6. Then f of x equals what? All right, well, let's do separation of variables. Negative 4 dx, and we'll integrate. ln absolute y equals negative 4x plus c. We'll exponentiate. We'll say that y equals plus and minus e to the c, e to the minus 4x. Let's say plus and minus e to the c equals b. So y equals b e to the minus 4x. And let's plug in our initial condition. 6 equals b e to the 0. So b equals 6, and so y equals 6e to the minus 4x. 6e to the minus 4x is choice C. Choice C for number 24. Okay, how about 25? 25 says big F is the integral from 0 to x squared of cosine t to the third dt. Then big F prime, so this is an FTC1 question. You want to take the derivative of this integral. Derivative undoes integral. Cosine, this goes in there. X squared to the third. Don't forget times the derivative of that inside function. And so I get 2x cosine x to the sixth. When I raise a power to a power, I multiply them. There's no plus c here. Don't stick a plus c on this. 2x cosine x to the sixth. That's choice D. Choice D for number 25. Okay, 26. 26 says the integral of ln of x over x dx. This is a u sub where u equals ln of x and du equals 1 over x dx. So this becomes the integral of u du, which is u squared over 2, or ln of x squared over 2. Don't forget the plus c. And we're going from 1 to, I imagine that's e, but I can't actually read it. 1 to e, yes. In fact, I'm just going to go with u bounds, and if I plug in a 1 here, I get 0. If I plug in an e here, I get 1. And so I'm just going to evaluate this from 0 to 1 and get 1/2 that way. So that's my choice C. C for number 26. Okay, 27. 27, the sum of two positive numbers, x and y, is 3. The absolute maximum of x to the third plus 12xy. This is a sum function, and I want sum prime. But I really want to get my sum function in terms of one variable, so I'm going to use this helping equation and say that y equals 3 minus x. So this becomes x to the third plus 12x 3 minus x, or x to the third minus 12x squared plus 36x. That's my sum function. So sum prime, 3x squared minus 24x plus 36. I can pull out a 3, x squared minus 8x plus 12. This factors as x minus 4, x minus, does it factor? Yes, 6 and 2. 6 and 2, 3. So we've got two critical values, 2 and 6 on S prime. S prime is an upturned parabola. So I've got positive, negative, positive. Gosh, thinking graphically sure does help. I don't have to do all that tedious plugging in of values. Oh my goodness. And so they asked me, when is this, or what is the maximum value? The maximum occurs at 2, so I want S of 2. S of 2, that's 2 to the third minus 12 times 2 squared plus 36 times 2, which is 8 minus 48 plus 72. So that's negative 40 plus 72, or 32 for choice D. D for problem number 27. Okay, and our last without calculator problem number 28. 28 says the sides of a cube are expanding, so I've got a ds dt here at a constant 2 centimeters per second. What is the instantaneous rate of change of surface area of the cube? Well, it's a cube, and each of these faces has an area, and the area is side squared. And how many faces does a cube have? It has 6. So the surface area is 6 times the area of one face, or 6s squared. So if I take the derivative of both sides of this equation, dsa dt with respect to time, I get 12s ds dt. Well, I have a ds dt, and I want to know this, but I want to know when volume equals 27. Well, I know the formula for volume of a cube is side cubed. So 27 equals s to the third. S must be 3. So I'm going to plug that 3 in there. 12 times 3 times 2, or 72. And the units are area units, surface area, so centimeters squared per second. And that's choice E. All right, that's the without calculator portion. And we were given 55 minutes. That was 41. Let's take a look at the with calculator portion. There's 17 problems here. And so number 29 says f prime equals tangent inverse of x to the third minus x. How many points is the tangent line to the graph parallel to the line y equals 2x? Well, if y equals f of x parallel to this, then those lines must have the same slope. The slope here is 2, so the slope here must be equal to 2. The slope of f must be equal to 2. So tangent inverse x to the third minus x equals 2. I'm going to graph this in y1, graph this in y2, and find my points of intersection. When I do that, I get choice A. Let me show you that. 2, and we want inverse tangent of x to the third minus x. And we want a 2. And if we do zoom, 6. Bum, 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 bum. Oh, they do seem to intersect. Let me check that again. They look like 2 places. Inverse tangent x to the third minus x equal to 2. Well, let's change that viewing window. -4 to 4 and -1 to 4. So there's my y equals 2. And look, once, twice, 3 times. Once, twice, 3 times. Whoa! 3 times. I wasn't expecting 3 times the slope to be equal to 2. Huh. Okay. So I change my answer here and I say D. Okay. 30. 30 says, which of the following are continuous but not differentiable at x equals 0? Well, cube root of x has an infinite slope here, an undefined slope here, so there's no derivative possible there. And you could figure that out by doing 1/3 x to the minus 2/3 and saying that's 1 over 3x to the 2/3. Why, look, at 0, I get a 0 in the denominator, so I have an undefined slope at 0. So 1 doesn't work. What about 2? Absolute value of x. Well, the limit of the slopes is definitely not the same from both sides of 0, so I know that one doesn't work. What about 3. X absolute X. Wow, what does that look like? Well, I don't know, but luckily this is the calculator portion of the test. So let's take a look. X absolute X, and we want graph. Oh, sure, the limit of the slopes is the same. The function exists. I don't have a reason not to believe that. Maybe I should change my viewing window a little. Negative 1 to 1. Negative 1 to 1. Yeah, that looks fine. I don't see any problem with that. So I like 3 there. Oh, look, 3 isn't an answer. Continuous but not differentiable. I liked 3. Why? Oh, not differentiable. Oh, 3 would be differentiable. Oh, so 1 and 2 are not differentiable. That means C. 31. It helps to read the question. Object moves along the y-axis with a coordinate position y of t, and the velocity v of t is square root of t minus cosine e to the t for t greater than or equal to 0. At t equal to 1. At t equal to 1. The object is moving downward, upward, so I want to know v of 1. That's square root of 1 minus cosine of e. Cosine of e. I don't know what the cosine of e is. Second quit. Okay, cosine of e. And my mode needs to be in radians because I'm doing calculus. And I get 1 minus negative 0.911, 1.911. This is positive, v is positive, so I'm moving up. And what about acceleration? A of t is going to be 1/2 t to the minus 1/2, or 1 over 2 root t. The derivative of cosine is minus sine, so I have plus sine e to the t times the derivative of that inside function, e to the t. Okay, and that's a of t, but I want a of 1, so that gives me 1/2 plus e to the 1 is e, so I want e times sine e. E sine e. E sine e is 1.11, so that's going to be positive, and so I have positive acceleration moving up, and that is choice D for number 31. D for number 31. Acceleration is positive, velocity is positive. This thing is moving up and with positive acceleration. 32. Let's take a look at problem 32. 32 says f prime of x equals sine 2 to the x. For all x's, what's the smallest value at which f has a relative minimum? So I want to know when f prime equals 0. And all of these values are between 0 and 3. Maybe I go a little over here. So let's graph our f prime graph. Sine of 2 raised to the x power. Okay, and we want negative 1 to 3 graph. I'm positive, and then I've got another one over here. Second, calculate 0. And I'm looking for the smallest value for a relative min. Well, this is going to be a max over here. And that's 1.651. This is a max. And then I go second, calculate 0 to find this other point of intersection over here. Enter. enter, enter. And I get 2.651. Well, that's choice E. E for number 32. I like E for 32. How about number 33? On the next page. 33 says the average value on the interval from A to B. Well, that would be x, no, that would be b to the third minus a to the third over, no, that's average rate of change. Let's try again. 1 over b minus a integral x to the third dx from a to b. Okay, the antiderivative of this is x to the fourth over 4 from a to b times 1 over b minus a. It's going to be b to the fourth minus a to the fourth over 4 times b minus a. I imagine I can take this further, but let's see if this is there. Oh, it is there. It's choice E. That's nice. I thought they were going to make me factor that difference of squares a couple of times. Okay, choice E, number 33. 34. The integral of x f of x squared dx. So if u equals x squared, du over 2 equals x dx. So this integral can be rewritten as 1/2 f of u du. Well, we know that big F is big F prime equals little f. So I guess I can say, and this goes from A to B. So I'm going to have, f of u. I'm going to have 1/2 big F of this b squared. It's a squared. I have to use u bounds because this is a u function now. F of b squared minus big F of a squared. Okay, so which one is that? That looks like A. Looks like choice A for number 34. It's 35. 35 says, which of the following integral expressions represents the area of the region bounded by the graph y equals 2 minus x and y equals ln of x and the x-axis? Again, sure I'm glad I know how to graph things. 2, 0, 2, ln of x. And so we're looking for this. And are we looking for the area of that? The area of the region. You know, all of these are dx's, which I don't like because I have to split this into two integrals in order to find this area. I would much prefer to do right minus left and rewrite these as y objects instead of x objects. But okay, it's multiple choice. I'll go with what they're talking about. I believe that point of intersection there is 1.557, though I could always graph this in y1 and this in y2 and confirm it, but the only values I see in the choices are involving this one. So the first integral goes from 1 to 1.557 for ln of x, plus the integral from 1.557 to 2 of 2 minus x. So 1.557 to 2, 1, 2, that's choice B. Choice B for number 35. Okay, let's take a look at 35A. 35A. 35A says a sphere volume 4/3 pi r cubed. Gas-filled spherical balloon increases 6 cubic inches, that's dV dt, for each degree of increase in temperature. Oh, with respect to, temperature. Okay, let's be careful about that. If the temperature increases at a constant rate of dt dt, 2 degrees per minute, at what rate is the radius changing? dr dt. Okay. Well, I know that dV dt times dt dt will be dV dt. So if I do the derivative of this, 4 pi, no, let's try that again. If I do this times this, I get dV dt. But I also know from our work in chapter 5, if we take the derivative of both sides of this with respect to time, dV dt is equal to 4 pi r squared dr dt. So where I see dV dt, I'm plugging in 12. And I need a radius. It says here when volume is 36 pi, and that's 4/3 pi r cubed. So I get 108 pi divided by 4 pi, which is 27. So r equals 3. So 4 pi 3 squared dr dt. That's 9 times 4 is 36. So I get 12 over 4 pi, or 3 over pi, is dr dt. 3 over pi is not one of my choices. I hate my life. Okay, the temperature increases at a constant 2 degrees per minute. Yes. The spherical balloon increases 6 cubic inches for each degree. 6 cubic inches for each degree. 2 degrees increases at a constant 2 degrees per minute. 2 degrees per minute. And this is inches cubed per degree. Yeah, that's 12. The derivative here, I bring down the 3, 4 pi r squared times dr dt. I like that. I put the 12 there. 9 times 4 is 36. 12 over 36 pi. So that's 1 over 3 pi. And 1 over 3 pi is choice B. Okay, 35A, choice B. Let's take a look at 36. 36 asks us to use the table. What is the average rate of change in G over the interval 0 to 5? So we want G of 5 minus G of 0 over 5 minus 0. G of 5, I read off the graph, is 5. G of 0 is 2 over 5 minus 0, 3/5. 3/5 centimeters per day. These are days on the bottom. These are centimeters per day on the top. And so that's choice A for number 36. Good. 36. 37. 37 says bamboo is 60 at time t equals t. Time t equal to 10. So let's say that big F equals, or big F prime equals G. So then if I integrate g from 10 to 20, that's going to be big F of 20 minus big F of 10. I know at time 10, the height is 60. And I'm looking for this. So I want to integrate from 10 to 20 this derivative function that they've given me, dt, and add 60 to it. Well, this isn't with calculator, this is counting up the area of each box. I'm going from 10 to 20, 10 to 20. You know, you could kind of call that a trapezoid, huh? 1/2, a base of 10, a height of 10. Base 1 is 1, and base 2 is 4. And so I get 5 times 5, or 25. 25 plus 60 looks like 85 to me. And so I'm going with choice D for number 37. Choice D for number 37. Okay, 38 also needs this graph. 38 says, which of the following intervals is G prime an absolute minimum on 0 to 20? G prime, absolute min. Well, G prime is the slopes of this graph. And if I want G prime an absolute min, I'm looking for the most negative slopes on the graph on 0 to 20. Okay, well, they look like they're happening somewhere in between 5 and 10. And that looks like choice C, number 7. Okay, that was 38, 39. The function f is continuous on the closed interval and differentiable on the open interval. So f of 0 equals -2, f of 5 equals 3. Well, according to IVT, we know that the function must pass through all the values from -2 to 3 because f is continuous on 0 to 5, which means f must have f must equal 0. There must be an x-intercept on 0 to 5. So that's f of c equals 0. That's 2. And mean value theorem, because we know that this function is differentiable on the open interval, mean value theorem would say f of 5 minus f of 0 over 5 minus 0. It's -2. No, that's 3 minus -2 over 5, which is 1. And so I know that f prime at some place must equal 1. F prime at some place equals 1. That's Roman numeral 1. So I've got those two, 1 and 2, and that looks like choice C for me on there. But what about Roman numeral 3? F of c must be -1 somewhere. Well, wait a second. Remember how we talked about IVT and we said we would pass through 0? Well, mustn't we also pass through -1? Careful. Read and think about all the choices. That one works too. And so we get a big old E here because of IVT. Because of IVT, f has to equal -1 and f has to equal 0. F has to equal all the y values between -2 and +3. Okay, problem number 40. Ooh, they like spherical things in this packet. 4/3 pi r cubed. Oh, we did this one. This was 40 is c 1 over 3 pi. That was also listed as 35a. 40 equals 35a. I wonder why I did that. Maybe I missed it when I constructed the packet. Now we've got a 40a. 40a says the integral of t to the fourth over t minus 1 dt. Okay, well, guess what? That's long division. T minus 1 into t to the fourth plus 0 t to the third plus 0 t squared plus 0 t plus 0. Okay, so that goes t to the third times minus t to the third, and I subtract. I get t to the third, which is t squared, which is t to the third minus t squared, and I subtract, and I get t squared, which is t minus t, and I subtract, and I get t, and I get plus 1, and I get t minus 1, and I subtract, and that's 1 over t. But wait a minute, that was just the division part. We haven't done the integrating part yet. So all we've done is establish that this integral is the same as t to the third plus t squared plus t plus 1 plus 1 over t. 1 over t minus 1 dt. Okay, antiderivative then would be t to the fourth over 4 plus t to the third over 3 plus t squared over 2 plus t plus the ln of t minus 1, and don't forget the plus c. And that looks an awful lot like choice A. Choice A for number 40A. 40A. Okay. 41. 41 says the region between y equals 1 over x, the vertical line x equals 1, and x equals e, this region, is rotated about y equals negative 2. The volume of the resulting solid. Okay, so they used washers here. They said that little r was 0 minus a negative 2. They said that big R was this y value minus a negative 2, which is 1 over x plus 2. So my integral from 1 to e of 1 over x plus 2 squared minus 2 squared dx. And don't forget the pi out in front. So that's a 4, that's a that, that's a that. This looks like choice D. Choice D for number 41. Okay, last page, 42. 42. The function g is given by integral from 0 to x over 2 e to the negative t squared dt. Write the equation of the tangent line to the graph of g at x equals 1. Okay, so we need an ordered pair. So I need to know what g of 1 is. And that'll be the integral from 0 to 1 over 2, 1 half, e to the minus t squared dt. Okay, and then I also need g prime of 1, which is the derivative of this function. So g prime is going to be e to the minus x over 2 squared times 1 half, and I want g prime of 1. So e to the minus 1/4 times 1 half. Okay, let's pull out our calculator and evaluate these things. I need the integral of e to the minus 0.5x, comma x, comma 0, comma 0.5. Oh, I didn't close that parenthesis. Okay, enter. So this is equal to 0.442. And then I need the derivative, which was 0.5 e to the negative 0.25. And that's equal to 0.389. Okay, and what am I looking for? The equation of that line. So y minus 0.442 equals 0.389 x minus 1. Well, that looks like choice C to me. Choice C for number 42. 42, choice C, because that's the only one that has R slope. Hey, look at that. Our Y value is different. Do I care about that? Kinda. Because it makes me doubt this then. All right, let's see. G of 1, plug in a 1 there. Integral from 0 to 1/2 of e to the minus. Oh, that's why. Okay, my integral was wrong. F int, we want e to the minus x squared, close that parenthesis, comma x, comma 0, comma 1/2. Okay. And so I get that 0.461. Okay, so I feel better about this, and so I'm going with choice C. C for number 42. Let's take a look at 43. 43 says the area of the region in first quadrant bounded by y equals cosine x to the third, y equals sine of x to the third, and the y-axis. Okay, so I need to take a look at that with my graphing calculator because I haven't a clue what that looks like. Cosine of x to the third. I want sine of x to the third. And I want first quadrant, so I'm going from 0, I don't know, going 0 to 10. And I'm going negative 1 to 1. Okay, let's see what happens. Oh my God. Yeah, let's read the question again. Find the region of the area in first. Am I in? I am in radians. Okay. I just don't want to be looking at that anymore. Zoom trig. Here, maybe if it's jiggy, it'll be better. No, it's just not any better. I think what I'm looking at is just this region here, but what about all of that? Well, let's see. So the cosine is the top function and the sine is the bottom function. Yeah. So let's then do the 0 to 1. First quadrant. Okay, that's better. Steps of 1, 0 to 1. Okay. There's my cosine thing. Here's my sine thing. And second, calculate, intersect, first curve, second curve, intersect. So 0 to 0.9226 Okay. In fact, can I do it here? Second, calculate integral, and I want to integrate to point. Oh, lower limit is 0. No, that's going to give me this one. No, I have to go over here. Math int cosine x to the third minus sine of x to the third, comma x, comma 0, comma 0.9226. And I get 0.709, which is choice C. C for number 43. Ew. 44. 44. A solid has a base region bounded by square root of x, and the vertical line x equals 4. So this is the ordered pair 4, 2. Okay. Each cross-section of the solid perpendicular to the y-axis is a square. Okay, it looks like the side of the square, if this is x and this is 4, side equals 4 minus x. And since our curve is y equals square root of x, x is y squared. So s equals 4 minus y squared, and the area, s squared, would be 4 minus y squared squared. I want to integrate that area, I believe. I'm looking for volume. 4 minus y squared squared dy, and I'm going from this y value to this y value, 0 to 2. So that's choice E. Choice E. And then finally, number 45, our last problem. 45 says fluid leaks out of a bottle at a rate of, so here's our dV dt is ln of 1 plus t plus cosine t plus square root of t. You know, those of you who are wondering where they came up with this equation from, you might want to take an applied math class. Okay, leaks out in, these are liters per minute. Liters? Milliliters. Milliliters per minute. The bottle contains 375 milliliters at time equal to 0. And we want to know t equals 60. Well, this is my rate function, and I integrate that rate to get the amount of fluid that's in the bottle. So I'm going to say that the integral of ln 1 plus t plus cosine t plus t root t, no, plus root t dt equals, from 0 to 60, equals the amount that I had at the beginning, 375, minus the volume at 60. So I'm going to find this integral and add 375 to it. Okay, so math, integrate, interesting function, ln of 1 plus x, close parentheses, plus cosine of x plus square root of x, close parentheses, comma x, comma 0, comma 60, close parentheses, and then don't forget to add the 375. Oh, look, it doesn't like my argument. Did I leave out a parenthesis somewhere? Yes, I did. Right here. Closing the cosine. Okay. Don't forget to add the 375. Yes, 375. And so I end up with, are you calculating it? Are you angry and petulant? Are you? Yes, you're thinking. I see you thinking. Well, I'm just going to let you think for a minute and say, what, isn't it wonderful to be alive? Still not done. There it is. 189.573 plus 375, and we get 560 leaks out of the bottle. Yeah, so 375 minus 189.573. I should have 185.427, and that's choice B. Watch out for English grammar. It's your friend or your enemy. Have a great day, everyone.